I want to show something pretty interesting here. The amperage coming out of the battery, I'm going to try to measure it here. It was measuring a little bit over 100 milliamps, and then it was dropping below 100 milliamps, bouncing back and forth. But the interesting part was the current coming out of the diode feeding back into the coil itself was measuring higher than the 100 milliamps. I'll see, unless my meter's measuring wrong, but I'll try to show it here. Maybe I'm zooming too far. Okay. So it's bouncing between under 100 milliamps, and every once in a while it'll go above 100 milliamps. Now if I measure the current flowing from the diode, measures between 300 and 400 milliamps. You know, I'm too close to the coil. It's messing things up. I'm reading. Just too close to the coil. I don't know. It's 900 milliamps, but then if I just measure the current on the main power line, it's under 100 milliamps. Measure the current coming out of the diode, 300. Now if I take and disconnect the diode, you can see my wires I've got here that are connecting to the neo magnets. Just two wires, and as the magnet goes around it touches it. Now if I disconnect the diode, so that's what's making all that extra current right there. That, and I added this magnet here. What I started out, I put the coil this way, and I made the core to where I had a north and south, and every time a south magnet comes past, it triggers it. All the north magnets I have a piece of tape on, so what it's doing is it's pulsing a north and south each time a set of north and south come by, that it fires on it. But I found out it runs better if I just flip that core up out of the way. It seemed like it dragged it down more, and I tried putting a piece of metal across here and it ran pretty good like that, but then I got the best results by adding these two 70-pound pole neo magnets right there, and I got the most speed and I got the least current draw. Like I said, it's under 100 milliamp draw. But it's pretty much held steady for the last 3 or 4 hours, like around 11:51. So yeah, it says it's only drawn I believe it. It doesn't seem to be drawing very much there. But then when I disconnect that diode, got the big flame there, really amplifying that current that's recirculating around. And then I've just got it going, the current going out of the diode here, coming back to hot side of the capacitor that's grounded right there, and then leading back to the coil, comes right back to the coil, so it pumps it right back into the motor and helps it run. But yet I'm only drawing 100 milliamp or less out of the battery. But like I said, circulating current is at least close to 500 milliamp total going into the coil. It's showing 700, 800 milliamp flowing through it, but yet if I measure coming out of the battery itself, I've got 100 milliamp right there. So it could be over 100, you know, could between 200 and 100. So, but it dips below sometimes. When it says 0, it's below 100. Now it's going between 200 and 100. So the total flowing into the coil is 600 milliamp, 700. But yeah, quite a big flame coming off those neo magnets when I trigger it that way. So it's real efficient that way. I just thought I'd share that with everybody. It's pretty neat.